this is the Investigating Rates core practical, and there's two parts to this practical. The first bit is investigating the rate of a reaction by collecting a volume of gas. Now there's two pieces of apparatus we can use for this, and I'm going to show you both today. The reaction is between some marble chips, some calcium carbonate, when they're in the chip form and when they're in a powdered form, because that will give them a different surface area. The powder has the bigger surface area than the chips. There is more surface exposed for the reaction. You're going to add some hydrochloric acid to that, 40 centimetre cubed. It's going to be the same amount added to each one. So the only different factor here is whether they are a larger chip or whether they are the powder form. So when you've got more surface area exposed, more collisions are able to happen in a certain amount of time. Hence it will give it a bigger rate of reaction. So the first one I'm going to show you is the gas syringe. And I'm going to show you this one with the marble chips syringe. Now as gas is produced into the reaction vessel here, when I mix them together, the gas pressure will push the gas syringe out, and you can measure how much gas is being produced as the reaction is continued. You will know when the reaction is finished because no more gas will be produced, no more product will be made. Now there's two ways to do it. You could just leave it to go for a certain amount of time and see how long it takes for it to reach, I think this one is 100 centimetre cubed or 100 mils of gas. Or you could do it over time, so you could get your stop clock and do it every 30 seconds and look at the rate that the gas is coming off. So I just want to show you how this one works. So you would put your acid in, and as soon as you've put it in, you must put the stopper on and start the stop clock. So as you can see, it's moving quite quickly, and the gas is being produced very quickly. If you've used a higher concentration, there's more collisions happening in there, and so the reaction will be faster, and so the gas will be produced much more quickly. Now we haven't even had a chance to get to 30 seconds on that one before we've reached 100. What would happen when you've got to the end of it and you've still got more time? You would just max out 100, 100, 100, 100 in your results table, and you would see that it would plateau out to show you that that is the end of the reaction. Okay, so that's using the gas syringe. That's obviously still reacting and fizzing away, you can hear that. The other one is with the powder. When you're doing your core practical, whichever one you decide to use, you must stick with for both. I'm just doing this to show you how both work today. So the other one is using a water trough. I've got a measuring cylinder here full of water. Let me just measure my 40 centimetre cubed of acid again. Okay. So let's see if this works here. A magic trick. It's a bit of surface tension to flip it over. And then place that underneath the water. So you know you've got 100 centimetre cubed of water in there to try and displace it with 100 centimetre cubed of gas. So, similar kind of setup to the gas syringe. This time this has got to be underneath the measuring cylinder to ensure that the gas is going straight into there. And you've got your divisions on the measuring cylinder here to see what you've got at what particular time every 30 seconds. So again, we will put in, oops, not that one. We will put in the 40 centimetre cubed of acid. So its reaction started straight away. And you can see the bubbling of gas that's being produced, carbon dioxide gas that you're making. And you can read on here every 30 seconds or less or more how much gas is made. And then you would compare the two. The steeper the curve from your results, the more gas that's produced the most quickly, the faster the reaction is. You could stir the reaction to make it happen a bit quicker, but if you stir for this one, you've got to make sure that you stir for the chips as well. Okay, so that's two methods. Now in the exam they might talk to you about one method and ask you for an alternative method, so it's really important that you've seen how both of these work. Remember, for rates of reaction, it's all about the rate of successful collisions. So here we have an example of some data you might produce from the two methods I've just shown. So you can see that you've got the time it takes to produce 40 centimetre cubed of carbon dioxide from the reaction. And you can plot that with a curve of best fit. And you can see where it is plateaued out at the end, that is where it is the end of the reaction. So a question might say, when was the end of the reaction? And it was actually at 5 minutes, because after that time it didn't produce any more gas. The other thing it could do here, which is your analysis of data, they could ask you to calculate the rate of the reaction, and that is the amount of gas that you've produced over time. So it's calculating the gradient. Now obviously this is a curve, so in GCSE maths you'll be used to finding the tangent of a curve. So using your ruler, you would perhaps need to draw a tangent to the curve, draw a straight line, and then from there calculate the gradient, which would give you the rate of the reaction. And you could do that for the marble chips versus the powder to see which one was the fastest rate.